part of the cell membrane. Okay. So this is a technique by which the ion current flow through a single voltage gated channel proteins can be recorded. ठीक है, द आयन करंट फ्लो कितना हो रहा है ना, एक वोल्टेज गेटेड चैनल्स में, उसके लिए करते हैं टेक्निक. दिस इज कॉल्ड, क्या कहते हैं, पैच क्लैम्प टेक्निक. ओके, नाम से पता चल रहा है. ए माइक्रो पिपेट इज टेकन एंड इट्स टिप इज अबर्टेड. इट इज अप्रोक्सीमेटली 1 माइक्रोमीटर, बहुत छोटा होता है इसके टिप, 1 माइक्रोमीटर का. इट इज इंसर्टेड ऑन द सेल, नॉट इनटू द सेल, इट इज ऑन द सेल मेम्ब्रेन. सेल मेम्ब्रेन पर लगाते हैं और उसको क्या करते हैं, फिक्स करते हैं, है ना, उसको पियर्स नहीं करते. और क्या करते हैं, इसको हम तो सक्शन अप्लाई करते हैं. ओके, सो दैट सिंगल वोल्टेज गेटेड चैनल इज देयर इनसाइड इट. एंड बाय अप्लाइंग ए सक्शन, ए टाइनी पैच ऑफ द सेल मेम्ब्रेन इज सक्ड अप. डिटैच नहीं करते उसको सकअप करते हैं बस, सो दैट इट सील्स द टिप ऑफ द माइक्रोपिपेट का टिप को सील कर देते हैं. ओके, एंड सच ए स्मॉल पैच ऑफ मेम्ब्रेन, इट इज कंटेनिंग minimum amount of channels, maybe a single or maybe more than a one. And there are different types of patch clamping, that is called cell attached patch. Here the patch of the membrane remains attached with the cell. इस तरह से attach रहता है, ठीक है. And what happened that to the other side of the pipette there are electrodes which are connected. उसे हम क्या करते हैं, उसको रिकॉर्ड करते हैं, ठीक है. Then there are whole cell patch, the patch of the membrane. What is happening? It is providing access to the interior of the cell. इस तरह से करते हैं, ये क्या होता है, सेल के अंदर में जाकर वो उसको कम्युनिकेट करते हैं. That is called whole cell patch. Okay, you can see this is communicating with the interior of the cell. Then there is inside out patch. The patch of the membrane is pulled from inside of the membrane to the outside. उल्टा हो जाता. Okay, just you should have the what is patch clamp technique. बहुत डिटेल में नहीं पढ़ना है, पोस्ट ग्रेजुएशन के लिए होता. Then coming on to the different types of transport processes. You all know that there are passive transport and active transport. Passive transport में कौन से होते हैं? Passive transport, what is, so the basic types is passive transport, then active transport. Apart from this there are also उसके types है. There are vesicular transport, endocytosis, exocytosis, है ना. Then apart from this there are other types also. They are called transport across epithelia, that is paracellular and transcellular transport. Passive transport, as you all know, there is diffusion and osmosis, है ना. डिफ्यूजन में क्या होता है हमारा, सिंपल डिफ्यूजन एंड फैसिलिटेटेड डिफ्यूजन. डिफ्यूजन में भी दो टाइप के होते हैं, सिंपल एंड फैसिलिटेटेड डिफ्यूजन. एंड अदर टाइप्स ऑफ पैसिव ट्रांसपोर्ट इज ऑस्मोसिस. देन इन द एक्टिव ट्रांसपोर्ट देयर इज टू टाइप्स. देयर इज प्राइमरी एक्टिव ट्रांसपोर्ट, इसमें और टाइप्स के होते हैं पैसिव ट्रांसपोर्ट में. डिफ्यूजन ऑस्मोसिस के अलावा देयर आर सम अदर टाइप्स, filtration, bulk flow, solvent drag. Okay, these are all types of passive transport. They are minor types, but major types are diffusion and osmosis. Then active transport is primary active and secondary active transport. Vesicular transport is exocytosis and endocytosis. Transport across epithelial, that is transcellular. Transcellular means through the cell, cell को क्रॉस करता हुआ जा रहा है बीच से. ओके, देन देयर इज पैरासेलुलर, इन बिटवीन द सेल, स्पेस के बीच जो है, दैट इज पैरासेलुलर. सो विल डिस्कस दिस टाइप्स ऑफ ट्रांसपोर्ट डिपेंडिंग अपॉन द यूज ऑफ एनर्जी. यू ऑल नो पैसिव ट्रांसपोर्ट, एक्टिव ट्रांसपोर्ट. एवरीवन नोज दैट एक्टिव ट्रांसपोर्ट यूटिलाइजेस द एनर्जी. अपहिल ट्रांसपोर्ट होता है ना, ऊपर की तरफ जाते हैं, लो से high concentration, and that is from high concentration to low concentration. Then energy, it is utilizing the energy and it is not taking up the ATP. Then one thing is saturation kinetics. Saturation kinetics क्या होता है? Anyone can tell? What is saturation kinetics? One of you and stand up and tell. Yes, you were telling. Then yes, you. What is saturation kinetics? Means whenever you are increasing the concentration, what will happen? All the available carrier molecule or channel protein, they are saturated. They have been full. So no further increase in transport. So it has reached a saturation state. So किसमें होगा saturation kinetics? Active transport में, passive में भी हो सकता है क्या? Facilitated में होता है, you all know. So saturation kinetics is followed by active transport, but it may also be followed by facilitated diffusion. Diffusion में भी हो सकता है. That is a type of passive transport. May or may not be present. Okay. Simple diffusion में नहीं होगा. It will not follow saturation kinetics. You all know simple and facilitated. Simple diffusion, if obviously it is not utilizing the energy, and what is the cause of this diffusion? Simple diffusion जो होता है high concentration से low concentration में चला जाता है. What is the cause? It is due to the random movement. Every molecule is in random movement all the time. So those जहाँ पे क्या होता है concentration ज़्यादा होगा, high concentration से low concentration में जाना. Those parts which is having the higher concentration, these will be more in the उसके जो molecules होंगे उसमें क्या होगा, thermal energy ज़्यादा निकलेगा, random motion ज़्यादा रहेगा. They will be striking the membrane. They will be striking more to the cell membrane, isn't it? That is called the Brownian movement. So it occurs because of the random thermal motion of atoms or the molecules. You can see here, one side is having high concentration of solute, another is less. So both are actually they are pushing this membrane, isn't it? But this side it is more. So this side, those sides is having the higher concentration, they are striking the cell membrane in more force. Okay, so net effect, net motion decides which way it will go. You can see this way it is also pushing and this way is also, but the net effect is in this direction, and this will happen, the transport, it will diffuse from higher concentration to lower concentration till it will achieve the equilibrium. Okay. So simple diffusional equilibrium कहते हैं. That is called the diffusional equilibrium. The net movement will stop when the concentration of the molecule is equal on both the sides. Okay. So that is called the diffusional equilibrium. Though the random movement of the molecules continue after the diffusional equilibrium is achieved also, the random motion continues, but on both the sides it is equal. That's why there is no movement after the diffusional equilibrium has been reached. The example you know, simple diffusion में क्या होता है? The transport of gases across the respiratory membrane. Oxygen, carbon dioxide transport. हमेशा क्या हो रहा है? Respiration से, membrane से क्या हो रहा है हमारा? Blood में जा रहा है, blood से इधर आ रहा है, isn't it? And also nitrogen, okay, different gases. Then there are alcohols also, aldehydes also. Okay, so there are different substances which can follow the simple diffusion, and these are lipid soluble substances. And what are the factors which are affecting the net rate of diffusion? कौन से substances है जो rate of diffusion को affect कर रहे हैं? The factors, obviously the affecting the diffusion is permeability, membrane permeability, है ना? Then obviously the concentration gradient, permeability उस पर depend करेगा. size, shape, charge. Okay, then the concentration gradient obviously, then also the electrical gradient, that is electrochemical gradient you can see, depends on the permeability and the electrochemical gradient. Factors that determine the permeability, the lipid solubility, जितने ज़्यादा soluble होगा उतना ज़्यादा permeable होगा वो. Okay, it is proportional. The size, if the size is less, smaller size, it will diffuse more. ज़्यादा बड़ा size का होगा तो मुश्किल होगा, है ना? Inversely proportional. Then thickness of the membrane. If the membrane is thick, through which it has to cross, there will be less diffusion. Inversely proportional. Then the cross-sectional area of the membrane. If more cross-sectional area, then what will happen? More diffusion will be more space to diffuse. Then temperature, it increases the rate of diffusion. It increases the Brownian movement. Okay. Then distribution of protein channels also. Okay. The rate of diffusion of lipid insoluble substances, जो lipid insoluble substances है, उसके लिए तो protein channel चाहिए. तो जितना ज़्यादा channel होगा उतना ज़्यादा diffuse होगा. Isn't it? It is proportional to the number of channels which are present per unit area of the membrane. Then also the pressure gradient, high pressure to low pressure. Okay. Then also it depends upon the electrochemical gradient. You can see in this diagram, two sides are there. This is the concentration gradient. Then this is the electrical gradient also. Okay. What happens that you can see here, both the sides are negatively charged. इधर क्या है, substances बराबर ही है दोनों साइड में, है ना? तो क्या होता है, अगर बराबर है तो क्या होता है, इधर होना नहीं चाहिए. दोनों साइड में अगर concentration बराबर है, then concentration gradient तो है नहीं, so it should not diffuse. But what happens that it also, if there is charge over it, if there is positive charge, you can see this side and negative charge this side. What will happen? The positive charge will attract the negative charges. So you can see these charges are going this side. Okay, this is the pressure gradient, high pressure to low pressure. Then this simple diffusion, the rate of this diffusion, it is governed by fixed law. तो एक लॉ है जो इसको सिंपल डिफ्यूजन को वो बताता है उसके बारे में. ओके, दिस लॉ टेल्स दैट द रेट ऑफ डिफ्यूजन is directly proportional to the concentration gradient obviously. जितना ज़्यादा gradient होगा उतने ज़्यादा होगा. Then it also is directly proportional to the surface area and inversely proportional to the thickness and also to the molecular weight, inversely proportional under root of molecular weight. This is the Fick's law. Okay. Coming on to the facilitated diffusion.